Welcome to the lesson on derivatives of products and quotients. The following theorem here provides a formula for the derivative of a product. So for instance, if the function f of x is expressed as f of x, capital F of x times s of x, where f of x here represents the first function in the product, and s of x here is another function that represents the second function in the product. Then the derivative of the product is just equal to copy the first function, differentiate the second function, plus copy the second function and differentiate the first function. And also provided that these s prime and f prime both exist. Now, using a simplified notation, we can denote the derivative of the product as y prime equal to f, that's first derivative of the second, plus second derivative of the first. Or instead of y prime, we can also use dy dx equal to f times the derivative of s with respect to x plus s times the derivative of f with respect to s. Now, to illustrate the formula, we consider differentiating the following function here. Note that the derivative of the product of two functions is not the product of their derivatives. That means I can just differentiate this first factor here times the derivative of the second factor here. Again, the derivative of the product, if this is my first, if I denote this as the first function, this is the second function, the derivative y prime is just equal to first derivative of the second plus the second times derivative of the first. Now, using that formula, we can obtain f prime of x. So to get f prime of x, you copy first the first factor. So you have 2x squared times the derivative of the second factor, 3x to the fourth minus 4 prime, plus copy the second factor, 3x to the fourth minus 4 times the derivative of the first. So 2x squared prime. Now let's go ahead and perform the derivatives here. So we have 2x squared times, now the derivative of derivative of this expression here is just the derivative of each term. So the derivative of 3x to the fourth is, so you multiply 4 and 3, 12. So that's 12x to the, and then subtract 1 from the exponent here, x to the third power, minus the derivative of 4 is 0. So I'll just put 0 there. Plus, copy this factor here. So you have 3x to the fourth minus 4 times, and then you differentiate this. Derivative of this expression is equal to, now you multiply the power here to the coefficient here. So 2 times 2 is 4. 4, copy x, and then subtract 1 from the power here. So you have x, or you put x to the 1, or just don't put any exponent. And then you simplify. So you simplify, you multiply this 2. You have 2 times 12, that's 24. 24x to the x squared times x cubed is x to the fifth. This times 0 is just 0. Next, you multiply 4x and 3x to the fourth. That gives you 3 times 4 is 12. So 12x to the 4 plus 1 is fifth. And then negative 4 times 4x is negative 16x. Then you combine similar terms. So 24x to the fifth plus 12x to the fifth gives you 36x to the fifth minus 16x. Now when doing your homework, it is just sufficient to input this expression here as your answer in MyMathLab. So you don't need to write it in its simplest form. Now to illustrate this, let us consider this item in your homework. Use the product rule to find the derivative of the given function. So we have y equal to the quantity 4x cubed plus 3 times the quantity 4x minus 5. Now using the product rule, the derivative y prime is equal to first, so copy the first expression times the derivative of the second plus copy the second times the derivative of the first. So you have y prime equal to 4x cubed plus 3 times the derivative of the second expression, 4x minus 5 prime plus, copy the second, 4x minus 5 times the derivative of the first, 4x cubed plus 3 prime. Then we go ahead and perform the differentiation. So you have 4x cubed plus 3 times the derivative of the second is 4 plus, copy the second function, 4x minus 5 times the derivative of the second. Derivative here is 12, so you multiply 4 and 3, that's 12. X, and then subtract 1 from the power, x squared. And the derivative of 3 is 0. Now, let's just go ahead and plug this expression into your homework. So now we'll go ahead and plug this into our homework here. So we have quantity, so you have 4x cubed plus 3, quantity 4. So instead of multiplication, you can put quantity 4 plus quantity 4x minus 5 times 12x squared. Oops. Squared. That's it. So you make sure that what you have here is exactly what you wrote as your answer. And then let's check the answer. See? You don't need to simplify it or write it in its simplest form when you input your answer. Another example. Use the product rule to find the derivative of the given expression here. Therefore, to find the derivative, we follow the formula y prime is equal to first, so copy 2x squared plus 3 times the derivative of the second, 3x plus 5 prime, plus, copy the second, 3x plus 5 times the derivative of the first, 2x squared plus 3 prime. This is equal to 2x squared plus 3 times the derivative of 3x, which is 3, and the derivative of 5 is 0, so times 3, plus 3x plus 5 times the derivative of the expression here. That means the derivative of the first term. That is equal to 4x plus the derivative of 3, which is just 0. So this would be your answer. You can leave your answer like this, or you can go ahead and simplify it. So you have 6x squared plus 9 plus 12x squared plus 20x. And then you combine similar terms. You have 18x squared plus 20x plus 9. Another example. Use the product rule to find the derivative of the expression here. So we have f prime of x is equal to the first. So that is 7x cubed minus x plus 6 times the derivative of the second, x squared plus 5 prime, plus, copy the second, x squared plus 5 times the derivative of the first, 7x cubed minus x plus 6 prime. So then you have 7x cubed minus x plus 6 times the derivative here, that is equal to 2x. Plus, you copy x squared plus 5 times the derivative of the expression here, that is equal to 21x squared minus 1. I'll leave my answer like this. Now for this example, we are given a function which is a product of 2x minus 9 and x squared plus 6. We are asked to find the equation of the line tangent to the graph of f of x at x equals 3. So to do this, we will first find the slope of the tangent line. Now the slope of the tangent line is equal to the derivative of the function evaluated at 3, at the given value of x here. So f prime of x, using the product rule, is equal to, copy the first, 2x minus 9 times the derivative of the second. Derivative of x squared is 2x. And the derivative of x is 0. Plus, copy the second. So copy x squared plus 6 times the derivative of the first, which is 2. Derivative of 2x is 2. Derivative of 9 is 0. And then let's evaluate the derivative here at x equals 3. So f prime at 3 is equal to 2 times 3 is 6. 6 minus 9 times 2 times 3. You plug in 3 to x. So that is 6 plus x squared. That means 3 squared. That's 9 plus 6 times 2. And then you simplify it. So you have 6 minus 9 is negative 3 times 6 is negative 18 plus 6 plus 9 is 15 times 2 is 30. 30 minus 18 is equal to 12. So that means your slope is equal to 12. Now to find the equation of the tangent line, we will then plug in our information to the general form of a line, which is y equals mx plus b. Now our m here is equal to 12, x is equal to 3. We don't have our y here, but we can compute for that y by plugging in 3 to the function here. So we will have y is equal to f of 3. So you plug in 3 here, so that is 2 times 3 is 6, minus 9 is negative 3. And then 3 squared is 9, plus 6 is 15. Negative 3 times 15 is negative 45. So then we'll plug in all this information to the equation here to find b. So you have negative 45 is equal to 12 times 3 plus b. 12 times 3 is 36 minus 45 plus b. So to solve for b, we will subtract both sides by 36. So we have negative 45 minus 36 equals b. Therefore, b here is equal to minus 81 or negative 81. So therefore, the equation of the tangent line is equal to y times m. Our m is 12, x, and our b is negative 81. Now for the second part here, we are asked to find the values of x for which the tangent line is horizontal. So when you say horizontal tangent line, this one implies that the slope is equal to 0. So that means we are going to solve for x for when the derivative is equal to 0. So that is when this derivative f prime of x equal to 2x minus 9 times 2x plus x squared plus 6 times 2 is equal to 0. So to to solve for x here, we will need to simplify the given expression here. So let's go ahead and simplify this. We have 4x squared minus 18x plus, then you just distribute this to each term inside the parentheses, and also this 2 here to each term inside the parentheses here. So you have 2x squared plus 12. That should be equal to 0. Then we have, you combine similar terms, you have 6x squared minus 18x plus 12 equal to 0. And then factor this out. So we have 6 as a common factor. And then we have x squared minus 3x plus 4 equal to 0. Now to find the values of x that will make this expression equal to 0, we will find the 0 of x here by using the quadratic formula, since the factors here are not that obvious. So using quadratic formula, we have x equals negative b, so negate b here, the coefficient of x. So negative of negative 3 plus or minus the square root of b squared. So that is negative 3 squared minus 4a is 1 times c, which is 4. All over 2a. And then you simplify this, you have 3 plus or minus the square root of 9 minus 16 divided by 2. Now notice that 4 minus 16 is negative. So this one will yield to an imaginary root. So therefore, we say that this one has no real solution or no real root. So with that, there is no x that will make our tangent line horizontal.